So hello guys, in this video we are talking about Deloitte Python data engineering interview question and answers. First section is Python core. In that we will cover oops, exception handling and parallel processing. First question is, can you explain oops and how do you apply it in data engineering? Answer is, I applied oops principle in my pipeline code through modulars class-based design. Through I will be honest that my focus has been on practical modularity rather than strict abstract class hierarchy. In ECDP, I structured my code into separate class for each responsibilities. A configuration class that load pipeline parameter, source credentials, and environment setting in the one place. Caller never access raw configuration directly. Source specific connector classes for Oracle, JDBC, Salesforce API, Smartsheet API, each encapsulates its own connection logic, pagination, and error handling. Transformation modules as separate Python script which with single responsibility, one for golden record resolution using XRF, one for raw to TL cleaning. This is separate means this separation means when the Salesforce API changed its pagination behavior, I updated only Salesforce connector class. Zero impact on Oracle or Smartsheet pipeline. That is the principal value encapsulation in data engineering. Second question: how do you handle exception and error in production pipeline? Data pipeline. Answer: my error handling in production work as two level: pipeline level and record level. Pipeline level in Modoc. In ECDP, I configured Modoc I use Modoc number for orchestration and retry the workflow to handle data quality failure automatically. When the validation rule fail, say null in mandatory clinical field, Nabu retry the workflow rather than failing the entire pipeline. This configuration reduces data quality error by 25% and prevent 15 hours of downtime in reporting window. Record level: PySpark bad record handling. For file ingestion like CSV, XML from S3, I use PySpark's bad record path option to route malformed record to quarantine location rather than crashing the job. Bad records are logged in metadata so that data team can investigate and reprocess. API call. For Salesforce and Smartsheet API call, I wrap request into try except block, catching HTTP error, timeout error, and connection error separately. Each has different recovery action. Timeout retry 401 second, retry token refresh 500-second alert, and half. This layer approach means a single bad record or transient API error never task down pipeline processing 10 million plus record per day. How do we handle parallel processing for large dataset? My primary parallelism tool is PySpark on Azure Databricks. I rely on Databricks distributed execution model rather than Python level threading. Specifically, what I have done in production: partition tuning, broadcast join, partitioner JDBC read. Partition tuning for our 10 million plus records per day pipeline in ECDP. I tune spark.sql.shuffle.partition based on data volume. The default is 200 was too high for smaller daily incremental and too low for full load. I set it dynamically based on input size, which contribute to 30% reduction in pipeline execution time. Then broadcast join. When I joining large fact table against smaller lookup table, for example joining clinical record against a reference data metadata table, I explicitly applied broadcast hint. So Spark send the small table to each executor rather than doing expensive shuffle join. This was a key part of 40% query speed improvement I achieved on 300 plus analytical queries. Partitioned JDBC reads. For Oracle JDBC extraction, I use PySpark num partition lower bound, upper bound, and partition column to parallelize the read across multiple executors dynamically faster than single thread JDBC read. The combination of those three techniques is how I handle data at scale. But Spark's distributed model does the heavy lifting. Example Python GIL. Next question. Explain Python GIL and how it affects your work. GIL means Global Interpreter Log. It is a mutant in C Python that allows only one thread on executed Python bytecode at a time. This means multithreading in PySpark in Python does not achieve true CPU parallelism of parallelism for compute-heavy tasks. In my day-to-day work, this is why I rely on PySpark rather than Python thread for large-scale data processing. My PySpark runs on JVM. The GIL does not apply to Spark distributed execution. Python in Spark is used mainly for driver-side logic. The actual data processing happens in JDBC connector. For any CPU heavy transformation, I use PySpark data frame operations building function rather than Python VDFs. Build in execute in the JVM and avoid Python serialized entirely. The GIL is also why I carefully about VDF in PySpark that bring data back to Python, which is both slower and grid constrained. I always prefer native Spark function where possible. How do you approach testing and validation of data pipeline? I will be straightforward. Formal PyTest based unit test is an area I am actively developing. My current validation approach is production proven but operate at the pipeline and data level rather than the unit test level. What I actually do, the Modoc Nabu validation rule. In ECDP, I configured Nabu rule to validate schema, null constraint, referring integrity and value range at every pipeline stage. Those rules fire automatically only run and flag various before bad record adjust downstream consumers. Next, row count and schema audit. I build Python script that run post load check, comparing source row counts against target count, validating schema consistency and logging result to control table. Any disturbance trigger as alert. End-to-end pipeline validation. For the FinOps POC, I validate the full SAP XML flatten by comparing 29 output hive table against separated records count and spot checking key financial hierarchy manually. Going forward, I am building PyTest skill and plan to add unit test for transformation functions, mocking source data with small simple data frames and asserting output schema and value. I want to be transparent about what I am non-do on this. How do you connect next section, that is data connectivity and loading. How do you connect Python to database and handle large data loads? In ECDP, I work with Oracle as a primary relational source using PySpark JDBC connector for execution. DF is equal to spark.read.format JDBC option URL comma Oracle URL / option DB table comma clinical records option user then dbult.secret.get in bracket scope comma Oracle dash URL and password dbutils.secret.get in bracket scope comma Oracle pass. Then option num partitions comma 8 partition column comma load date option lower bound comma 220 to 220-01-01 and upper bound 2024-12-31. Dot load. Key specific flow. Credential always from Azure Key Vault via dbutils.secret.get, never hard-coded. Partitional reads. Num partition with date or ID column, so multiple executor read in parallel. Predatory pushdown filter apply at JDBC level, so Oracle return only needed rows, not full table scan. Incremental loads. Watermark based extraction, so we only pull records change since the last successful run, not the full table every time. For the outbound direction, I also built sync workflow, pushing processed data back to Oracle from Lakehouse. Zero manual intervention, full automated. Next question: how do you handle large scale data transformation? All my large scale transformation work in PySpark using native data frame operations, never pandas for anything above the MB. For example, in ECDP golden record execution, I built XRF based identity resolution system that unified record from Oracle Salesforce Smartsheet into single golden record per entity. This involved multi-source join, deduplication logic, and confidence scrolling, all in PySpark using window function and aggregation. Raw to TL cleaning. In maintaining architecture, raw to trusted layer handle null replacement with domain fault, date standardization across source format, string normalization for clinical code, and deduplication using raw number, window function partition by entity key. How do you handle batch processing? SAP HTML flattening means FinOps POC. I face deeply nested SAP functional XML and flatten it into 29 relation table using PySpark XML reader and custom Python parsing logic. This was the hardest transformation I have done. SAP inheritors are deeply recursive and irregular. I always use built-in PySpark function over UDF. Built-in run in JVM, are catalyst optimized and are significantly faster than UDF Python. Next question: how do you handle batch pipeline processing large files, say 1 to 10 GB? In ECDP, I regularly process file in this range. Daily clinical data load and full hierarchical migration up to 20 terabytes total. My approach for large batch files, like first columnar format conversion. Raw files arrive as CSV or XML from S3. First thing I do is convert them into iceberg Parquet format in the raw layer. Parquet columnar storage and compression means 5 GB CSV become roughly 1.5 GB on disk and is 4-5 faster to read downstream job. Schema enforcement upfront. I define explicit struct type schemas for all file reads. No schema infer. Infers requires Spark to scan the entire file first, which doubt input-output with the explicitly schema. Spark read once. Partition strategy. For iceberg table, I partition on date column, load data or study data. This means query filtering by data skip entirely partition dynamically reducing scan volume. Incremental or full load. I build both strategies. Full load for initial migration, incremental watermark based for daily run. Incremental load processes only change the record, so 10 GB historical table might only read 15 MB processing on given day. Checkpointing. For multiple stage pipeline, I write immediate result on iceberg table between stage. The failure is for stage 4 rerun from stage 3 checkpoint, not from original 10 GB source file. Section 3, REST API and Service Integration. How do you consume REST API in a data pipeline? In CDP, I integrated two REST APIs in production, Salesforce and Smartsheet. Salesforce API, I authorized Salesforce API, REST API to pull a CRM record into integration layer. Key things I handle: authentication to OAuth to authentication, client's credential follow, token store the Azure keyword, refreshed before expiry. Build API for large record set versus standard REST for similar queries. Pagination: Salesforce uses cursor based pagination via next record's URL. I loop until this field is null. Rate limit: Salesforce stores daily API call limit. I batch request and monitor usage to avoid hitting limit mid pipeline. Smartsheet used for pulling project metadata and clinical study tracking data. Smartsheet uses simple token based authentication. I handle row level update, both reading Smartsheet data and write status update back to Smartsheet from pipeline output. Next question: how do you handle authentication between multiple systems? Security is not non-negotiable in pharmaceutical sector. My standard pattern across all systems in ECDP: Azure keyword plus Databricks secret. All credential, Oracle password, Oracle Salesforce credentials, Smartsheet token, S3 path access key are stored in Azure keyword and accessed at runtime via debutis.secret.get in brackets scope comma key. Zero credential in code, notebook or configuration file. Salesforce authenticator: Salesforce client credential flow. I fetch a short-lived access token and pipeline starting up client ID and secret from keyword. Token is passes as barrier header on all subsequent API call. Before each pipeline run, I check token expiry and refresh proactively. S3 access is using Boto3 with IAM rule-based access, no static access key. The key Azure, the Databricks cluster has IAM rule attached with list privilege S3 permission scope to specific bucket. Oracle JDBC: username and password retrieved from keyword at job start, passed to the JDBC connection string at runtime. Connection pulled from for the duration of the job. This pattern means if secret is located, only keyword entry change, no code change, no reproduction needed. Architecture and design: how do you design scalable data pipeline architecture? In ECDP, I implemented modeling architecture end-to-end, raw, trusted, and raw, bronze, silver, gold layer. On Apache Iceberg on S3. Raw layer: data load extractly as received from source, CSV, XML, JSON, API resources. No transitions. Every record get metadata column. Ingestion timestamp, source system, file name, batch ID. Nothing is ever deleted from raw. It is permanent audit trail. It is source of the truth. This matter enormous in pharma where regulatory audits required proof of what data arrived and when. Silver layer: business level schema enforcement, null handling, deduplication, data standardization, referral integrity check. Data here is reliable and queryable. Golden record execution resolution. XRF based unification happen at this layer. Gold layer: business level aggregation, view, joint data set, KPI table optimized for consumption by BI tool and downstream ABM workflow, partitioned by query performance. Design principle I follow: idempotency. Every pipeline run produces the same result on retry. I use iceberg merge operation, never be blind append. Monitoring. Each layer is independent job. A failure in trusted does not run wrong. Configuration driven. Source pipe, source mapping, transformation rule, load strategy are metadata configuration, not hard coded. Adding new source means adding configuration entry, no writing new pipeline code. Auditoring, auditability. Iceberg trap. Iceberg time travel let me query any table as it existed at any point in time. Critical for regular compliance. How do you use Gate in terms data engineering context? Gate is standard practice in my team. My workflow like branching main from production develop for ingestion, feature for individual work items. No direct commit into main. Pull request. Every change review before merge. I include what changed, why, and any development or config step needed. Databricks Gate ingestion. I use Databricks repo to sync notebook with our Gate repository. Notebooks are version controlled along Python module. No untracked notebook change floating in the space. CI/CD pipeline deployment is automated. Code merge to develop triggers a CI run that develops to staging. Merge to main, deploy to production. No manual file uploaded. Gate ignored. Secret local environment files .pyc file and Databricks auto-generated files are always executed. This discipline meant that in ECDP every production change was traceable, reviewable, and revisable. Tell me about Apache Iceberg and why do you choose and what benefits did you get? In ECDP, we choose Apache Iceberg over plain Delta Lake for S3 based lakehouse because three specific requirements. First, acidic transitions, time travel. Second, time travel for regulatory audit, and third, schema evaluation without rewrite. Acidic means clinical trial data get updated, corrected, and appended from multiple sources concurrently. Without acidic guarantee, concurrent write would interrupt data. Iceberg optimized concurrency control handles with safety. Time travel for regulatory audit trails. Pharma is heavily regulated. Auditor need to see exactly what data looked like at specific point in time. Iceberg snapshot based time travel let me query. Select chart from table name for system time as of database name. This is not possible in plain Parquet file. Third, schema evaluation without rewrite. Clinical data schema change at study revolves. New column get added. Type get refined. Iceberg handles schema evaluation without rewriting existing data files. Unlike Hayu, which required full table rewrite. The result 20 terabytes plus data of pharmaceutical data with full acidic compliance, time travel capability, and zero manual partition management. Honest gap answer. Question 14. Do you have experience with event driven programming in Python? My pipeline trigger are currently schedule based via ADF rather than event time. I use concept well. I understand the concept well. Producer emit event. Customer react independently and typically through a message queue like Azure Service Base or Event Hub. In practice, my ECDP pipeline use ADF trigger on schedule and file arrive trigger on S3 via ADF storage event trigger, which is the lightweight form of event driven design. A new file landing in S3 trigger the ingestion pipeline automatically without pulling. Full driven architecture with Python, a synchro or message query in a area I am actively developing beyond my current project scope. 15 question. How familiar are you with unit testing in Python? I will be transparent. Production PyTest with mocking is something I am actively building. My current validation is at pipeline and data quality through model number rule and pass post load updates. This is a skill gap I am considered curiously addressing, and it won't hold me back from delivering. I have maintained 99.9% data up to uptime in production without it through strong data quality validation at the pipeline level. Tell me about time you automated runtime development work. Tell me about your time you automated runtime development work. In ECDP, setting up pipeline infrastructure for new data source required manually writing SQL configuration file, table definition, column mapping, load strategy flag. It was taking 15 hours plus work across the team. I built a Python script that auto generate those SQL configuration file from simple input template. A engineer fill the source table name, target table, column list, load type. The script generate full config. This eliminate 15 plus hours per week for manual setup. Tell me about your POC you deliver at business impact. The FinOps Dataverse POC is clearest simple. The ask was who we would migrate complex SAP financial hierarchy data into modern data platform. The original estimate was 8 weeks. I delivered it in 2.5 weeks, 16% faster than estimate. What made it complex? Like SAP financial hierarchy are deeply nested XML with regulatory structure. I had to praise XML, understand the hierarchy logic, and flatten it into 29 relational Hive table that made business in sense to Catalyst. I choose Python plus PySpark for praising PySpark XML reader for structure, custom Python logic for hierarchical traversal, and Spark for parallel flattening into Hive. The output went simultaneously into Delta Lake on Databricks and Snowflake. Dual target to give the client flexibility on their analytical platform tools. The POC sign-off secured $5,000 in immediate revenue for the business duties and opened the door to larger engagement. How do we handle data governance and compliance in regulated environment? Pharma is one of the best regulated data environment. 21 CFR Part 11 in additional requirement audit tells access control and data lineage are non-negotiable. In ECDP, I address governance through Unity Catalog, iceberg time travel, raw layer immunity, secret management, and audit log.